Welcome all of you. Welcome to ANIMATHS. This is my second video. This is part 2 of lines and angles. Okay, so the video before this in lines and angles, we had discussed in detail what are the complementary angles, what are supplementary angles, small problem sums, slightly tricky problem sums and complementary and supplementary angles were done. Okay, now here in this video we shall be proceeding with the lines and angles chapter, but then you will see that we are taking up 3 or 4 more things, sums based on 3 or more concepts of lines and angles. Now this is, I consider, one very important topic for lines and angles, for 9th standard geometry. Why? Because the concepts that we learn here, the concepts that we are learning here in this topic will be useful in our triangles chapter, in our congruence chapter after this. So please don't try to skip this and go to triangles chapter. And another thing I always say, please watch the videos even of lines and angles part wise. Go part wise. So I think this chapter might take about 3 videos. Let us see how many it takes. So let us start with the sums. Do watch the video from the beginning to the end, because there are many important sums, types of questions that regularly come in exams that will be explained here. Also there are many questions, many methods of calculations which are explained here, which will be useful in other chapters as well. So see to it that you are listening carefully, and you can even make a note of these particular what methods that we are using. Then let's start with the questions. Now here in this part of lines and angles, we shall be taking up the first thing, that is angles on the same straight line. Like this is a straight line, and on this there can be not just 2 angles. You are generally used to seeing 2 angles, but it is not just 2 angles. You can have any number of angles on this straight line. Angles on the same straight line. The thing is, they all add up to, if I take A, B, C and D, A plus B plus C plus D, all add up to always 180, because the total angles of a straight line is always 180 degrees. The other thing that, because before I start with the sums, I am telling you the things that we are using in this chapter. The next thing that we will be using in this chapter is adjacent, supplementary or linear pair. Adjacent supplementary angles or linear pair means this wasn't, this was the sum total of any number of angles on a straight line. But adjacent supplementary means, first thing, adjacent angles are those angles which will have one arm common. So you have this arm common between these 2 angles. That makes these 2 angles adjacent angles. You might have heard of that, adjacent. Adjacent angles. So this is, these 2 angles are adjacent. But then remember one thing, we can have adjacent angles even without they being supplementary. Like this is a pair of adjacent angles, but they are not supplementary. But then when 2 adjacent angles meet up to form 180, then they are called adjacent supplementary angles. So these 2, if this is x, this is 180 minus x. This is an adjacent supplementary pair. This is plain adjacent, that is because one arm is common. So this is what we are going to use, adjacent supplementary angles. This is also called a linear pair. Linear pair. Remember, the word linear comes from line. So linear pair is whenever we have angles on the same straight line, a pair of angles on one line is called a linear pair. Now this is a straight line, and in this we have 180 minus x and x. So this forms a linear pair or adjacent supplementary angles. Now another thing that we are going to use in this video, another thing is that is called, another one that is called vertically opposite angles. Okay, now vertically opposite angle is not a very new thing. I know all of you know this very well. Okay, vertically opposite angle is nothing new. But the thing is, even then mistakes are made very often in VOA. We also call it VOA sometimes, or vertically opposite angles. Yeah. Now what are vertically opposite angles? Here, vertically opposite angles happen only when two straight lines intersect. Then this and this angle is equal. Also this angle and this angle is equal. Okay, so that makes vertically opposite angle. Now remember, I just said two straight lines should intersect. Only then we get vertically opposite angles. Okay, now there are sometimes, we get angles like this and then somewhat like this. Okay, this is also not correct. Let me, not getting it correct like this. Let me make it properly. Somewhat like this, and then this goes like this. Now the students, the moment they see something like an X, they will make this equal to this and this equal to this. But you see, this is not one straight line. This is definitely not one straight line. Even this can be called a straight line. This is not a straight line. So you don't have any vertically opposite angles in this diagram. They have to be only if this line would have been like this, then you get vertically opposite angles. Okay. So vertically opposite angles is another thing that we are going to use in this chapter. Okay, this video. Another thing that we are going to use here is angles around a point. This angles around a point can be made using straight lines. Then you have lots of vertically opposite angles. This and this vertically opposite, this and this vertically opposite, this and this vertically opposite. Okay, but then this and this is not vertically opposite because I haven't made this diagram with any straight lines. Okay, these are all partial line segments. Okay, these are all just, they have come and they came and met at this point. So these are not straight lines, since therefore no vertically opposite angles are there. But then we have, what we are going to use here is, let's say A, B, C, D, E and F. There are 6 angles. A plus B plus C plus D plus E and plus F makes a 360 degree. So angles around a point, whether you have made it using straight lines or you have made it without using straight lines, okay, without the full thing is not a straight line, of course there is a straight line, then they always, the angles here also, all these angles always add up to 360 degrees. This is called angles around a point. Okay, so now let us take up few of the questions based on this. Okay, so this is our next question. We have to find the value of x. Now clearly the question has also told, and we know the question generally will say, okay, so if the question will tell A or B is a straight line. Okay, so if they have told A or B is a straight line, then 3x minus 5 plus 55 plus x plus 20. That is, I am adding up all the angles here. I am adding up all the angles here, and I have told any number of angles on a straight line will always make a 180 degrees. So now what I have here is, I have a simple linear equation. 3x plus x is a 4x. 55 minus 5, that makes a 50. 50 plus 20, that makes a 70, is equal to 180. 4x, try to simplify the equation as far as possible before you take it to the other side, that to avoid mistakes. Okay, so this is 180 minus 70, which is equal to 110. Yes, this is 110 degrees. So now what is the value of x? X is 110 by 4, which is 55 by 2, which is 27.5. Okay, if you have difficulty in finding this, you can do it like this: 55 to This is 2s are 4 and 15 and 7 and 14, 1, put the point here, this 5. 27.5 degrees is the value of x. Now that the sum doesn't end there. Okay, now the sum is asking for what are the values of all the angles in this diagram. Okay, so the values of all the angles in this diagram, one is 3x minus 5, which is 3 into 27.5, 3 into 27.5 minus 5. That gives me, here let me multiply, 15, 1 is a 22, okay, 2, that is 8, 82.5 minus 5, okay, that is 77.5 if I subtract. Now here I want to tell one thing, people will go wrong here. Okay, how you should subtract? You should put the 5 here and not here. People will put the 5 here and they go wrong. Okay, this is supposed to be 0, then this is 7 and this is, so be very careful when you are subtracting decimals. 77.5 degrees. Okay, so that is my value of the first angle, that is, this is 77.5 degrees. This I already know, this I know. This one is x plus 20. X plus 20 is how much? It is, x is 27.5 plus 20, that is 47.5 degrees. So this is 47.5 degrees. Now what I have to see is, I should always check whether on adding these angles, okay, whether on adding these three angles I am getting my 180 back or not. That is the thing we must always see in our examination. So here it is 47 and 77 and this, okay, 110, let's take it like this, 47.5, that is a 1, 15, 1, okay, so 5, 125 plus 55, this 55, okay, that gives me a 180. So if you are able to get your 180 on adding the values of these three angles, your sum is correct. Let's take up another question which is based on, this question is based on, let's see what it is. The diagram itself will say what it is. Now they have told three coplanar lines intersect at O, find x. This is the question, find x. And what are the coplanar lines? The coplanar lines are, here I have A, B, C, D and F, E, F. Okay, A, B, C, D and E, F. These are the three coplanar lines. Now, this word, what's the meaning of this word? Coplanar lines means these three lines will have to lie in one, they have to lie in one plane. Now if you see, my board is one plane, okay, this board is one plane, means, and I can even say if I have a notebook here, supposing I have a notebook here, okay, so this is again one plane and even this is one plane, okay. Supposing I am drawing these lines on this plane, then if I draw these lines, remember all the lines should be lying on the plane, they should not be sticking out like this. The lines should be all be lying on this plane only, like this. So what I mean to say, the line should not be, even this is a line but it is sticking out of the plane. So when they say coplanar lines, they mean that all the lines are lying on one plane. Okay. Now how does it make a difference to the sum. If supposing the lines are not on the same plane, okay, then you cannot have vertically opposite angles. Two vertically opposite angles should always be lying on the same plane. Okay, so now let us continue with the sum. Three coplanar lines intersect at O, find the value of x. Now see, in these questions we should complete most of the sum in the diagram. Another thing I want to tell all my students, you must always copy the diagram in your notebook or in your answer sheet, wherever. Even if you are practicing at home, see to it that you are copying the diagram on the paper. Okay, because you don't have the option to write even in the question paper in the exam. Okay, so you should have the option to write in the diagram. Only then you can get the sum very easily, very quickly. Okay, so here in the diagram, if this is an angle 3x, this is VOA, vertically opposite angle. If this is 2x, this is 2x VOA, and this is 5x, again VOA. Okay, so this is a quick sum which can be done. I will do the sum, it can be done in two ways, but I shall be doing the sum only with the upper half, only this much. This much is enough for me, this much. Okay, I'll not take this part into consideration, it's not required. There can be others might do, that is also correct. So what I do here, 5x plus 3x plus 2x is equal to 180 degrees, because it's a straight line. So this much you see is a straight line, angles on the same straight line. Okay, that makes 10x, 8x plus 2x, 10x, 180. X is equal to 18 degrees. Yeah, now what do they want? Then we have to find the initial three angles. They had given us this, this and this, these three. Okay, so let us find these three angles. We have got the value of x. So 5x angle, wherever we have 5x angle, it is 5 into 18, which is equal to 90 degrees. Okay, wherever we have a 3x, that is 3 into 18, which is a 54 degrees. Okay, 54. And wherever we have 2x, 2 into 18, which is a 36 degrees. So clearly I can say, if I add up these, okay, I can get a 180. So see to it that on adding them you are getting your 180. Now I was talking about another method also. Yeah, I said there is another method which is correct. You can add them all up. Okay, 2x, 3x, 5x, 2x, 3x, 5x. That gives you a 20x. This side 10, that side 10. 20x is equal to 360. 20x is equal to 360. You can do that also. X is equal to 360 by 20. When you write that x is equal to 360 by 20, again x comes to 18. So as I said, you can do by any of the two methods. Okay, when you write this, when you add it like this, just give them the reason why you did so. And what is the reason? The reason is angles on the same straight line, because your teacher will want to know why you have angles on the same straight line. Your teacher will want to know why you have added them and equated them to 180. If you are using this, you write angles around a point. That much is enough. Okay, so in geometry questions, your answers, whenever you form equations like this, they should be accompanied by, they must be accompanied by reasons. Okay. Okay, so this is our next question. In the given figure, ray OC is the bisector of angle AOB. So here I have OC, this is ray OC, which is the bisector of this angle AOB, and OD is the ray opposite to OC. OD is the ray which is opposite to OC. Show that angle AOD, this one, is equal to DOB, which is this. You have to show that. So how do we proceed? Now they have told that AOB is the bisector. Yes, that is this line OC is the bisector. So I can always take this as x and this as x. Okay, both are equal. Therefore, see the way we should write it. AOC is equal to BOC, that is given. Okay. Angle BOD, this BOD, angle BOD is equal to 180 minus BOC, no doubts about it. Yes, this is 180 minus this, and AOD, angle AOD is 180 minus AOC. Okay, therefore, now if these two angles are equal, that is AOC is equal to BOC, I can write here 180 minus BOC. Yes, I can write here 180 minus BOC. If I write here 180 minus BOC, then I can clearly see that angle AOD is equal to, this part is same as BOD. So I know that if given with angles, all of you can do it. The problem starts when the same sum has been given without proper angles, that is with x you have to solve, or you call this proving type questions. Then starts the problem. Now it is a problem because you can't understand how to write it. Okay, so this is the way you have to write it. So we have not written anything unnecessary. Generally you end up writing a lot of unnecessary things in these things. Okay, so one quick statement saying these two are equal because this is the bisector, one statement because it is supplementary, same statement because this is the supplementary. Only thing is you do some substitution over here from here, and this line and this line becomes equal. Therefore these two angles are equal. Okay, so this was one proving type of question. We'll do similar another question. This is also very similar type. Now here is one question which never gave us the diagram. If two straight lines intersect each other, then prove that the ray opposite to the bisector of one of the angles so formed is bisects its vertically opposite angle. Now this means prove that. Okay, PT I'll always write for prove that, remember. Sometimes I might even forget to tell you. So here this is, okay, now these two straight lines intersect each other, and this is, let's take this as one of the angles formed, this one. Bisector of this is this line, okay, and the ray opposite to the bisector is this, that is it has to go in the same straight line, but then it is called a ray opposite. So here, if this is the bisector, that let's take it as O, A, B, C and D. Okay, we named it for our convenience. So this is, if this line, let's say OX, and this is OY. So if OX is the bisector of angle AOD, then this is an X and this is also an X, because they have told it's a bisector. What do we have to prove? We have to prove that this line OY is also a bisector of angle COB. Now how do we prove it? Let's write angle AOX. See, you know what it is. Writing is a problem for you. So learn it from here. Angle AOX. Okay, angle AOX is equal to angle XOD. That's given. Yes, bisector. Then AOX is also equal to YOB. AOX is also equal to YOB. Now which is YOB? This. Why? Because of VOA. VOA, right? Vertically opposite angles. Okay. Now let me take up another one, which is angle DOX. Where is angle DOX? Yes, angle. So angle DOX is equal to angle COY. COY. Why? Why is angle DOX, this one, is equal to this? Again VOA, right? DOX is equal to again VOA. Okay. If DOX is equal to COY, then can we write YOB is equal to COY? YOB is equal to COY. Because AOX is equal to DOX. Because AOX, now here, these two I have told are equal. Why? Because these two are equal. AOX and DOX are equal. Okay. So YOB is equal to COY, you can write in bracket, angle AOX is equal to angle DOX, you can write it that in bracket. This is X. Okay, now since I have been able to prove this angle is equal to this angle, these two, therefore OY is the bisector. OY is the bisector. OY bisects angle COB. OY is the bisector. OY bisects angle COB, because we could prove this part is equal to this part. Now here is our next question. Prove that the bisectors of two adjacent supplementary angles. I have told about adjacent supplementary angle right at the beginning of the video. So these are two adjacent supplementary angles. Let me name this as a AB, and this is the point O, and this is C. So these are two adjacent supplementary angles. Now this sum didn't have a diagram, we are making the diagram. So remember, in these questions students are not able to get the diagram itself. Okay, they find it difficult to get the diagram. Now why so? These are, first thing, adjacent supplementary angles, you have to know to make it. The second thing is bisectors of two adjacent supplementary angles. This is one bisector, this is the other bisector. Okay, so they are saying this is a 90 degree. Now let me name that also, OY and OX. It becomes easier. See to it that you are naming the diagram. Why? Because it's not that without naming you aren't getting the concept. You get the concept very well without naming. But how will you write your proof without names? Okay, so see to it that you are naming them. The first thing that you do is, after drawing the diagram, is to name. Then you get your sum very fast. So second thing is, now COY is equal to YOB, isn't it? COY, this is equal to YOB. COY is equal to YOB. That is because this is the bisector. Second thing, COX is equal to AOX. COX is equal to AOX, COX and AOX. Then the third one, AOX plus XOC. Okay, now how do we write it? AOX. Now see, angle AOX plus angle XOC, that is this one, plus angle COY plus angle YOB, all add up to 180 degrees, because they are all part of, together they form one straight line. Yes. Now AOX plus XOC plus COY plus YOB. So here I shall be making some substitutions. What is it? Just watch. Remember, we have written COX is equal to AOX. So where there is AOX, I'll put a COX again. So COX will be repeated. Okay, XOC and COX is the same thing. So COX plus, I'm making it COX plus, okay, COY, let me leave it as COY only, and YOB is again equal to, so this I'll substitute with this COY because they are equal, is equal to 180. Don't do the other type of substitution where don't substitute COX with AOX, okay, and COY with YOB. Then you will not be able to reach the answer easily. Put a 2 here because I am getting 2 COX's. So this is a small factorization, kind of taking common, you can say. Okay, this is 180 degrees. Okay, COX plus COY is equal to 90 degrees. I bring that 2 down. Okay, it becomes a 90 degrees. COX plus COY, that is this much plus this much, is how much? XOY, and this is the angle which was formed by the bisectors. Okay, so two adjacent supplementary angles, bisectors of two adjacent supplementary angles include a right angle, means they make a right angle. So XOY is equal to 90 degrees, hence proved. Okay, so this is one of the shortest. There can be other methods also. I am not claiming this is the only method, but then this is one of the easy methods to remember and easy methods to write down. It is best if you are doing a mathematical proof to write it in the mathematical language rather than write long sentences. Okay, that takes a lot of time and it doesn't prove the point very much clearly like it does with this. Okay, so that's it in this video. We have done all proof that questions in lines and angles, this part at least. Okay, that is in the next video. Lines and angles is yet to be continued. In the next video we shall be doing lines and angles. We'll be taking up that is the parallel line part. Okay, lots of you have lots of doubt about corresponding angles, co-interior angles, or alternate interior. So learning up so many types of angles. So we shall be doing parallel lines based questions in the next video, that is lines and angles part 3. Okay, so till then, that's it for today. If you have liked the video, do not forget to like, share and subscribe. Thanks all of you. Bye then.